Hello everyone. In this question, it is asked that we are to prove that the product 1 raised to the power 1 times 2 raised to the power 2 times 3 raised to the power 3 up to n raised to the power n is less than or equal to 2n plus 1 upon 3 whole raised to the power n times n plus 1 upon 2. Okay, so this looks very convoluted at first. Okay, so in order to prove that, we start with the information of weighted arithmetic mean and geometric mean. Okay, we know that for regular cases the arithmetic mean is greater than equal to the geometric mean for positive or non-negative real numbers. Okay, so we consider for the non-negative real numbers, oh sorry, not w1, for the non-negative real numbers, say x1 x2 up to xn with respective non-negative weights, w1 w2 up to wn. The weighted arithmetic mean will be greater than or equal to the weighted geometric mean. Okay, this means that the arithmetic mean will be that this weight w1 is corresponding to this real number x1. Similarly, this w2 is corresponding to this second real number x2. Okay, so the weighted arithmetic mean is given by w1 x1 plus w2 x2 plus wn xn, and this is divided upon by w1 plus w2 up to wn, and this is greater than or equal to this product x1 raised to the power w1 times x2 raised to the power w2, and this goes on up to xn raised to the power wn, and this entire product is whole raised to the power of 1 upon w1 plus w2 up to wn. Okay, this is the weighted arithmetic mean and weighted geometric mean. Okay, so symbolically this can be written as, if I take a dummy variable k goes from 1 to n, this becomes wk xk upon summation k goes from 1 to n wk will be greater than equal to the product k goes from 1 to n xk raised to the power wk, and this whole thing is raised to the power 1 upon summation k goes from 1 to n wk. Okay, so in order to prove this theorem, we take a particular case for this for this equation. Okay, we are taking a particular case. Considering the case, considering the case where xk equal to k and wk is equal to k for every k belonging to this set 1, 2, 3, and so on up to n. Okay, this means that when k is 1, x1 and w1 both are 1. When k is 2, both x2 and w2 both are 2, and so on. Okay, up to when k is n, this xn and wn both are equal to n. Okay, this is the condition or case we are considering in this equation. Okay, so if we put this value here, xk equal to k and wk equal to k, this will become k times k, right? So this will become summation of k square. So this becomes summation of k square as k goes from 1 to n, and in the denominator it is only wk, right? And wk is equal to k, so this will become summation of k. K goes from 1 to n, summation k is greater than or equal to, in this product, since both are k, xk is k and wk is k, this will become product of k goes from 1 to n, the product of k to the power k upon summation k goes from 1 to n, and this will become k again, since wk is k, so this will become k. Okay, so this is the situation we have now after the substitution. Okay, so now we can use the summation formula. This is summation of the squares of first n natural numbers. Okay, so this is going to be 1 by 6 times n upon n times upon n plus 1 times 2n plus 1, and this is divided by, this is the summation of first n natural numbers, so this is half times n plus 1, and this will be greater than or equal to, I'm going to substitute the values of k in this, inside this bracket, inside this product. Okay, so for k equal to 1, this is 1 to the power 1. Similarly, for k equal to 2, this is 2 square. For k equal to 3, this is 3 cube, and so on. This goes on up to n to the power n. And here, in the power, this is again summation of first n natural numbers. So I can use that formula one more time, n into n plus 1 upon 2. Okay, so now let us see what are the terms that can be cancelled. This n times n plus 1 can be cancelled, and this 2 and 6 can be cancelled. So 3 is left in the denominator. So in the left hand side, we have 2n plus 1 upon 3 is greater than equal to 1 times 1 times 2 square times 3 cube. This goes to n to the power n, and this becomes, this 2 will go to the numerator of the power, right? So this will become 2 upon n times n plus 1. Okay, so on changing the sides, the power, if I change the, if I take this power to the other side, this fraction will invert itself, right? So this will become 2n plus 1 upon 3 whole thing raised to the power n times n plus 1 upon 2, and this is greater than equal to 1 to the power 1, 2 square, 3 cube, and this goes up to n to the power n, right? So we are finished. Just we need to change the sides of this inequality, and this is completed. 3 cube n to the power n is less than or equal to 2n plus 1 upon 3, and this is n into n plus 1 by 2, right? So I think this was the question. Yes, so we have completed the sum. Okay, so this was it was slightly tricky. You have to consider this weighted arithmetic mean and weighted geometric mean first of all, and then you take the particular case where both the weight and the observation values, that is xk and wk, are k each. Okay, and then you take for every k in this set, you take this x1 equal to 1, w1 equal to 1, then x2 and w2 both equal to 2, and so on. So you can use this summation of squares of first n natural numbers and summation of first n natural numbers. Okay, so this is it. If you have any doubt in any step, you can highlight. You can, if you think there is any mistake in any step, you can highlight in the comments. Okay, this is finished. Thank you.